So, hi there everyone. MEM School of Engineering, Department of Mechatronics Engineering, online classes, subject unlock devices and circuit, unit number 3, a stable multi-operator using IC 555 timer. In last class, we discussed with the basic model of IC 555 timer with the internal circuit explanation. So, in this class, how to design a stable multi-operator using IC 555 timer. Okay, that means how to connect. So we know that unstable multi-vibrator. So unstable means there is no stable state in the process. That means the charging and discharging in the linear way. Okay, not in the any stable condition. So what is in the stable and unstable? Stables mean the circuit should should be in a stable state or in the constant state for the particular time. But example, square wave. So in square wave, the Tn will be defined for the particular time period. Okay, that is stable state. But in the sine wave, for example, if you take the sine wave for the positive cycle, the system will not be stable because it will vary every time period, every microsecond or millisecond. The data of the output will be varying. So that is unstable state. Okay, by this way, we can define this unstable multi-operator. That is, there is no stable state, but we are getting the output as a square wave using the capacitor charging and the discharging method. Okay, so first, how to connect the circuit of IC555 timer to form the unstable multi-operator. Okay, this is the model. So last class we know that we discussed with the 6 and 2. So 6 is threshold, 2 is trigger. Okay, 6 is threshold, 2 is trigger. Okay, so that is here we are connecting the capacitor through the trigger circuit. So that is the charging capacitor. So here we are connecting the capacitor C1. So that is define the discharge capacitor with the smaller value. So we are connecting the nanofarad only. We are connecting the capacitor. So as well as we connect the discharge value to this value. Okay. First condition. Okay, by VCC, that is charging condition. So this is the charging direction. Okay, charging direction means first direction. So when VCC, for initial condition, it will be 0. So it will given to the transistor. So it will be a open circuit. Here, what happened? It is a open circuit. So the VCC value given to the resistor 1 and 2. The capacitor charging and the capacitor charge through the R1 and R2 directly go to the C value. Okay, so when capacitor charging, that is capacitor will charge for the particular time period. Okay, so so up to the comparator value will be changed. So comparator value 0 and the 1 and vary it will be varying. So then it will state of the output, the flip-flop output will be changes to the 1. But the state of flip-flop vary that is 1 and vary the transistor will be enabled. That means the transistor will be closed. So the power supply direct connected to the 0. Okay. So one thing we need to follow in this circuit. Okay. By the way, if you are connecting the R1 and R2 means the capacitor charging through the R1 and R2, but the discharge of the capacitor will done through only the R1. So the capacitor charging time will be high. So the T1 time period will be very high. But in the reverse, that is discharging time, that is T off time will be very less. Okay, so we can get the 50% of duty cycle between the input and T on and T off. So we need to go for the another process, that is we are adding extra diode in the output side. Okay, so by this way, the charging process done by the R1 and R2 as well as the discharging process also done by the R1 and R2. So the T on and TF value will be equal. So we can get the perfect square wave in the output. Okay. So this is a model. So this is a charging and capacitor. That is charging done through the R1 and R2. So discharge done through the R1. So this circuit will define the concept. Okay, this is the formula for the duty cycle, that is R1 plus R2 divided by R1 plus 2R2. The output time period T is equal to T1 plus T is equal to 0.693 into R1 plus 2R2 into C. Okay. So this is the method for varying the value. Okay, so already we are connecting the diode to the process. Next one, monostable multivibrator. So here the name mentions the multivibrator model. Monostable means it is a single stable state. Okay, that is capacitor charging to the particular location, but it will not be discharged in the linear way. It will directly go to the zero. That means it is having the uh, one stable state in the process. So this monostable multivibrator mostly used for the rectangular waveform generations in the circuit. Okay, whenever I am giving the trigger means you will get the value. Okay, this is the different application of monostable multivibrator, that is generating time delays, frequency division, pulse width modulation, switching the relay. So this is the diagram for the triple fly timer. Okay, here what we add. Okay, in previous circuit diagram as stable, the trigger value connected to the capacitor. Okay, the trigger value connected to the capacitor, but here we are connected to the external source. Okay, so external source means the external uh, square wave. So that waveform will define the comparison between the comparator 1 and 2. So whenever the trigger is applied, the comparator 2 will be enabled. So output get the sampled value. Okay, output la என்ன ஆகும் ஒரு pulse வந்து generate ஆகும். So this is the circuit. This is the monostable multivibrator, that is triple five timer as the monostable multivibrator circuit. So this is the time period for monostable multivibrator, that is T is equal to 1.1 into RC. Comparison between the monostable and multivibrator. Okay, so let's see the overview of these two. So a stable multivibrator generally defines the square, for example, for the square wave generator. So that is capacitor charging and discharging will define the output value of flip-flop. It will produce the square wave in the output. In monostable condition, it will generate the output when the trigger is enabled. Okay, when trigger is enabled, the comparator 2 will be enabled. So the flip-flop will be reset. Okay, that condition, that is capacitor will linearly charging. When the trigger applied, it will goes to the zero. Okay, that means we are getting the one pulse. Okay, as well as goes to the second concept. So second, when trigger again, it will be capacitor will be charging. So after the trigger will enabled, the output goes to zero. So this concept repeatedly done by the different trigger sources. Okay, so it is called a monostable multivibrator. So there is one stable state in the second half. Okay, so these two are mostly used in the delay circuit. Okay, in microprocessor we have a delay, that is for delay between the one instruction to another instruction. So there is no operation condition. Delay after a particular time period. For motor on and off conditions, we can generate the different monostable and unstable circuit. Okay, so this is the concept of monostable and unstable multivibrator using IC 555 timer. Okay, thank you. So next class we will see the voltage regulator. That is, what is voltage regulator and what are the types of voltage regulator. So where it is used, okay, how we are perform the voltage regulator using the operational amplifier in the real time field of industries. Okay, so thank you.